Okay, cuts, my camera cut out. Yeah, it's not like in all these videos that I put on there. The memory just goes, it's an old camera. It's like an old phone, 4 or 5 years old. I gotta move. Okay, I think I was just about the spot where I was gonna give you the overall equation for the circuit. So I wrote it down. Here's my overall equation. If you look at it, it should make sense. Current through I3 must be equal to I1 and I2, so make an overall I equation. I did that. There are many choices here. You can go with a lot of different choices. Like, for example, you could say that I1, since it comes around here and then splits into I3 and I2, is equal to I3 plus I2. And then you can go with that. It doesn't matter your equation that you make up as long as it makes some sense. You could say that I2 is equal to, I2 equals I3 and I1, or whatever, whatever. Let's say, I got I1 coming this way, so it would be equal to I3. This would be I2 plus I1 equal I3. Also, one I got up there. So there's a lot of choices that you have of which equation overall that you can use. I'm just going to use this one. I put it up there first, so I'll go with this one. As long as it makes sense. Does it make sense that I3 is coming along here and it's splitting and I've got it going in 2 different directions, so these two must be equal to that. It just makes sense, right? So set up an overall equation. That's the first step. Okay, now, what we're going to do is we're going to pick a spot to start. I always start over here on the left so I stay out of the way. Over here, it's not going to work, right? So I pick a spot over here on the left. And I start from some juncture point, a junction point. That's where get the splitting and the combinations. So I'll start from here. And what you do is you just decide to go around the circuit. Just go around it. I'll turn you this way a little bit. Just go around. You can go around, just go around. You need to go start here and get back here. Or you can start here and get back here. Again, I'm picking the left side so I can stay out of the way. But I'm going to start here, and I can go up and around like this to get back. I can go up and around like this to get back. I could go down here and go through here. I can go through and go through around there. I have actually 4 choices of starting from this point and getting back to this point. So what I'm going to do is I'll start from this point, and I'm just going to make my way around the circuit. And what I'm going to do is write an equation. Okay, what we're going to do is construct 2 equations. Okay, if you have 3 lines, and that's what you'll have in your circuit, you'll have 3 lines. You won't go into 4-line circuits. No, we'll just stick with circuits with 3 lines. If you have 3 lines, you need to make 2 equations. To make 2 equations, what do you mean? Well, here we go. Here's what we're going to do. We're going to make an equation that deals with the current and the resistance and the voltage that are used in the circuit. So we got to think, voltage is I times R. So what I'm going to do, though, is if I want to get the voltage drop, remember that word voltage drop, voltage used around a circuit? If I want to know the voltage from here to here, and it has to be all of it in a circuit. Once you go around from one starting point around the other side of the circuit, come back, you've used all the voltage up. So your total voltage from here to here, what's left over should be 0. You'll use all the voltage. You'll have no voltage left. So once I make my path around, which way I choose, once I get back to my starting point, I will have used up all the voltage in the system for the circuit that I have available. These resistors will use up that voltage, and they'll just use it all up, and it'll be all gone. So what I'm going to do is set up an equation that has the voltages as I start from here and make my way around here, and I go from some voltage to 0. Voltage is I times R. So current times resistance. So remember that, current times resistance, that's voltage. Okay, so as I go around the circuit, I'll start from here, and I'll go up and around. I'll just go around I1. So I'll start with this one first. That's number 1. So I'll go up in here, chug it, chug it, chug it, chug it, choo choo. As I go around, oh, here I finally encounter something. So once I encounter something, I got to write that down in my equation. So I've encountered a resistor. And remember, I need to know how much voltage this resistor is using, because we're going to start with a certain amount of voltage available. As we go around the circuit, we use it all. So voltage is I times R. So how much voltage would this resistor use? I times R. Okay, let's see. I is I1. Now remember, the overall, let's go back to what we're doing. I don't care what the heck are we trying to find, right? Remember, we're trying to find the current going through this line, and this line. We're trying to find the current. So I need to know how much current goes along this line, and it encounters this resistor. And so what I do is I write the equivalent to voltage for this resistor. V is I times R. So I going through this resistor is I1, and it's a 30 ohm resistor. All right, so I times R. Now, I like to write it, this is I times R, literally, but I like to write, I don't like having my variable out front. That's what we're going to be solving for. I don't like that, so I switch it. It's okay, multiplying, it doesn't matter. So I like putting 30 I1. All right, so 30 I1. And all I'm doing is when I encounter something, I put it in my equation. I'm constructing an equation. When I encounter something, I write it down. Now, here's the second little blurb. You ready? Here we go. You got this over here? If go around in selected direction. If go around, that's what we're doing. We're going around in the selected direction. What do you mean? So I'm going around in the direction that I originally decided to guess that the current would go. Remember, I'm guessing at that. I could be right, I could be wrong. Doesn't matter. We'll still get the right answer. So if I go around in the direction of the current that I wrote down, so in the same direction, then use a negative in front of I. Well, I'm going to put out in front of the 30. I mean, it's in front of the I, but I'm going to put it in front of the 30 because I put my variable out front. Remember, that's just me. I like my variable in back. I like my number in front of the variable. So use a negative. So use a negative if you decide to make a loop in the direction that the current is set up for around that loop. Okay, so I've dealt with this first resistor. I'm going to come down here, and I have a choice. I can go all the way around and back if I want, or I can cut through and back. I'm going to cut through. We'll see what happens. If I decide to cut through, the next thing I encounter is this 45-volt power source. It's a power source. I just put 45 volts. But it doesn't matter. It doesn't matter. 45 volts. So now I have to deal with it. That has to go in my equation. All right. If go through battery or power source, let me put PS here, power source. Doesn't have to be a battery, but power source. Negative to positive. Remember, the short end on a power source is negative. The large line, the longer line is positive. And that's what we're doing. We're going through negative to positive. We're going through negative to positive. I'm going around like this, going negative to positive. If I do that, use a positive in front of the voltage. So what do you mean? I put the voltage in my equation. 45. I'm not going to write V. I don't have the space for those. But I'm going negative to positive, so I put a positive in front of the volt source. Boom. Okay, all right. Next thing I encounter is this resistor and this resistor. Actually, this represents the internal resistance. There's that word, the internal resistance, or the terminal voltage of the power source. Each power source has its own voltage resistance. That voltage has to be used to overcome its own resistance. And typically that's written right next to the power source or the battery. So I have one down here. This is 1 ohm resistance. This is 1 ohm resistance. So this represents the internal resistance of the battery. But look, this is in series with that. So I can just add those together, right? Yeah, I could do that. So as we move along this line, I'll encounter 41 ohms of resistance. And I like to put my 41 in front of the current. Remember, now we got a current coming down here. But the current going through here, I chose as I3. Again, you don't have to. You can put I1 here, I3 here, I2. It doesn't matter. It's going to work. Just follow the rules. Trust me, okay? You can trust me. So as I go down this line, I am now along line I3. So I put an I3 here. And I'm going in the direction that I chose to set up my current going. If we go in the same direction, we use a negative in front of the I. But again, I like putting my number in front of the variable, so I'll put a negative in front of the 41 I3. So I have created an equation. Now, what happens? When I get back to here, we set this equation equal to 0, representing that we've used up all the voltage along this line, all the voltage that would be used here, here, and here. We've used it all up as we go along and back to my loop. That's one of those called Kirchhoff's rules. Okay, Kirchhoff's rules one of Kirchhoff's rules is that you have, when you go around a loop on a circuit, any circuit, it doesn't have to be complex, it can be a combination circuit, that you use up all the voltage along that circle. Okay, so I have created an equation. Sweet. All right, hang on, what we're going to do with that, okay? We need 2 equations. You need to create 2 equations. We've created 1. I have 3 different currents. You'll need 2 equations to create. So you'll see why in just a minute. Okay, let's create another equation. I created one for a loop starting here and going through the middle and ending here. What I'm going to do now is I need to make another loop. It doesn't matter. As long as it's a different loop. I can start from here and go around here. I can start from here and go up and around here. Oh, I can't do that because I haven't included this. It just has to include the things I haven't included yet. So I haven't included these guys. So these guys have got to be involved. So I can go around like this. I can go around like this. I can go around like this, as long as I include the things that haven't been included in my second loop. All right? Okay, it's fun, right? Fun. I'm going to start out in the same spot, which I'd recommend that be consistent. And I'm going to start the same way. I'm going to go up around here because I've already created that part of that equation. So that would be relatively quick for me. Then I'm not going to cut across. I'm going to go around here, and that includes the things I haven't included yet. That means my two equations have included everything in the circuit, and that's what I need to do. Well, let's write that second equation down that I've chosen to go in this direction. That will start out negative 30. This is actually I1. I should put that in there. That's I1. I1, that's important. I missed that, which was important. Now, negative 30 I1. When I get here, I am not going to cut across here. So I'm not going to have this in my equation. I'm going down here. All right, now I'm going down here. The 20 and the 1 are in series, so I'm going to add those together, 21. Now, what line am I on? I'm on the I2 line. I am on the I2 line, so 21, I2, that looks like a Z, I don't like that. 21, I2, but I'm going against the direction that I just chose, arbitrarily chose at the start of the problem. If I'm going around against the direction I set up, then I don't put a negative, I put a positive. So if I go around against my setup direction, I put a positive. Okay, just trust me, it's gonna work. All right, now I hit this battery, hit this power source. That's 80 volts. However, I'm going through it positive to negative. And that means, okay, if you go through negative positive, use a positive. If you go through positive negative, use a negative. It's the opposite. So I have to put a negative here in front of the 80. Then I'm back to where I started, so I've used up all the voltage. There's no voltage available left around that portion of the circuit. We've accounted for everything. And remember, these are voltages. Volts. This is I times R, that equals voltage. These are voltage, and I've used all the voltages up to go around that circuit. Incomplete. Kirchhoff's rule, which says once you go around a circuit, you've used all the voltage up. You have none left. All right, so what? Now what? I've got two equations, two sweet equations. All right, so what I'm going to do here, in case I run out of energy, I run out of battery space, I'll stop this video and pick it up. I'm going to upload this video and then erase it on my camera and start over again. I start for part 3. Okay, so we'll come back to what I do next in part 3 right after this message from your local sponsor.